Just a couple of things to help you. Well, this is one thing, and I'll do another video for the other. Things to help you on chapter 5, or test number 5. I'm going to be asking you to prove something regarding vectors, and I wanted to show you how mathematical proofs do in general. We'll use vectors, so your proof on the test is going to look very much like this, but I don't care, because I want you to see what happens with mathematical proof. Some people think that you may just be able to prove things by just picking any vector out of the sky, with numbers and all that, and putting that in and showing that whatever you're trying to prove is true. But that just could be a lucky coincidence. You need to be able to show with any vector that something is true. For example, I want to show that two vectors added together, u plus v, that it is equal to adding them in the other order, v plus u. I want to show that. You may think, well, it's just a matter of taking an arrow here and then adding it to that, and if you do the first one and then do the second one, you'll get that. And that's true, but that's not a proof. It could have been just a lucky coincidence of arrows. That's not enough. You need to be just so bomb-proof, sorry to use a pun, when you do a proof. You need to just be so rigid and careful with a proof, because you are saying to the world, this is true, and there's no counterexample that you can come up with that is going to go against what I have just said. So you need to be very sure and very cautious, and this is how you do it. You say let. The big word is let, because then you're letting the world see, oh, okay, it could be anything. You're going to let u be some vector a1, comma, b1. A1 could be any number. B1 could be any number. This is the I component, this is the j component, and we're going to just let that be anything. And that's the solidness that you have with a proof like this, because it can be anything, it will work not most of the time, but all of the time. We're going to let v be the vector a2, comma, b2. And now I'm going to start with u plus v. U plus v is equal to the vector a1, comma, b1 plus the vector a2, comma, b2. And I know from my definition of addition that this is equal to the vector a1 plus a2, comma, b1 plus b2. But I know that I can, within these are just numbers. These are not vectors anymore. This is like 2 plus 3. 2 plus 3 is the same as 3 plus 2, because addition in the real numbers is commutative. I can switch them. And the same here. I can switch them. And so I do. That's equal to a2 plus a1, comma, b2 plus b1. But that is v plus u. And I've got it. I'm done. So if the trick with proofs is make it general so that it works for everything, and you're going to do that by selecting variable letters, and then do the algebraic manipulation like you need to do so that you get the result. And now I have proved that u plus v is equal to v plus u. Go thou and do likewise.